Welcome back to mathsolver1117, the place where maths become fun. Today we are starting a brand new topic from calculus, that is derivative. No need to worry, even if you have never studied calculus before. By the end of this video you will understand what a derivative is, where it is used and how it's work. So imagine you are driving a truck. You look your speedometer and it says 60 km per hour. 60 km per hour. So consider at initial, this is initial position where time is 0 and this position is A. This point is point A. After 10 seconds, your position is at point B. It's mean you change the position in time 10 seconds. So this is the rate of change of position with respect to time. So this is called derivative. So now I will write the definition of derivative. What is derivative? So you will easily understand that the rate of change is called derivative. So by this example you understand how the position is changed with respect to time. So this is the rate of change and that is called derivative. Now derivative is not only for the position of the cars, buses. Derivatives are used to measure how fast anything changes, like temperature, population, stock prices, water level, and even how your heart beat. This is also measured by derivative. So now I will tell you another deeper concept to understand what is the derivation. Now consider a curve. This is a curve. And consider a point on the curve, like this is a P point. Now we will draw a tangent line on this point. This is the line of tangent. Now you can see the straight line touch the curve only at one point, that is P point. So the straight line touching the curve at only one point is called tangent line. The slope of this line tells us how steep the curve is at that point. So we will say this tells us the change. So you can write slope, that is equal rise by run, and this is called the derivative. So this is called the slope of this is called the derivative. Now you easily understand that the derivative of a function at a point equals to the slope of its tangent line at that point. So slope of this tangent line represent the derivative at that point. Now I will tell you a real formula to calculate the derivative. Now first of all, consider a function. Let's suppose f of x equals x square. You have to calculate derivative at x equals 2. So we will use the formula. The formula of this is derivative f dash of x equals limit h approaches to 0 f of x plus h minus f of x divided by h. Now we will use this function. So first of all, at x is equal to 2, we will calculate f of at x equals to 2 plus h. So 2 plus h and f of x equals x square, it's mean x places by 2 plus h, so 2 plus h whole square. That is 4 plus 4h plus h square. Now f of 2 equals 2 square, that is 4. Now we will apply the values in this formula and get x plus h at x is equal to 2. So this will becomes limit h approaches to 0, 4 plus 4h plus h square minus 4 divided by h. So 4 and 4 are cancelled out, then take h as common, so 4 plus h square, 4 plus h divided by h. H and h are cancelled out. Now apply the limit on this. The limit h approaches to 0. When you apply the limit on this, you will get 4 plus 0, that is equal to 4. So your derivative is 4. So the slope of the curve at x is equal to 2 is 4. Now I will tell you some real life applications. Now real life applications. Like suppose rocket launch. First of all, at height t is equal to 0, it covers the distance of 0 meter. But height at t is equal to 5 second, distance will be 500 meter. So the speed of the rocket is the derivative of height with respect to time. It's mean 500 divided by time, that is 5. So 100 meter per second, that we can, the speed of the rocket, this is equals to the speed. So 100 meter per second means in 1 second the rocket covers 100 meter. Now another example of this will be, next one is, we say stock market. At stock market So at day 1, rate is $100 and at day 2, 130. So rate of change will be as this will be day 3, let's suppose. So rate of change will be that we can also describe by delta, means 130 minus 100 with respect to time, day 3 minus day 1. So this is the derivative in finance. Now another example, consider this is a container and the water level at t is equal to 0 is 0 liter. But after time is equal to 10 seconds, this container is filled and water level is 40 liter. So the rate will be equals to the 40 minus 0 and 10 minus 0. How fast the water level is rising? So you will say that derivative will be how fast water level is rising. So this is called the derivation. Now in this video you understand derivative means how fast moving some object. It is the slope of the curve. We have used the limits to calculate and it is used in science, business, engineering, everywhere. If this video helped you understand derivative for the first time, subscribe mathsolver1117 because in the next video we will learn how to use basic derivative rules like power rule, product rule and chain rule step by step. Best of luck for your exam. Stay tuned.